All right, everybody. This is going to be another one of those lessons that deals directly with that graphing stuff that we spent so much time doing at the beginning of the year. So this is section 2.1. This is specifically about transforming quadratic type functions. So these are all quadratics, which are parabolas, and we're just doing the same thing that we did with absolute value functions. We're going to be stretching them, we're going to be shrinking them, we're going to be shifting them left, right, up, down, flipping them. So again, it's all stuff that we've already done before, so this should not be too bad. I'm going to pick a couple examples out of the book. I'm going to walk my way through those examples with you so that we can see them and so that we can talk about them, and then we should be pretty much done. As you look through the book, you're going to notice all of the same words that we've already talked about and all of the things that we've already gone through. Just so that we can be on the same page, let's just make sure that we have all of those things down in our notes so that we know exactly what we're looking at. So this is section 2.1, and this is transforming quadratic functions. Now remember, we had talked about, vertical stretches, vertical shrinks, horizontal stretches, horizontal shrinks, and everything. But we have a general form of an equation. All of these are going to be derived from the parent function. The parent function is going to be x squared, but then there's a whole bunch of things that we can really do to that parent function. So we could say y equals a. A is the thing that's out front. And then we have x minus h squared, and I should change this color because that's what I'm trying to do here. X minus h squared, and then we have, actually, hang on. So let me rewrite this. B times x minus h squared, and then we have plus k. So those are all the things that we talked about. We have the number out front that's doing something. We have the number inside that's doing something. We have this number inside that's doing something, and we have this number inside that's doing something. So let's just go through and re-talk about all of the things that can happen. We can say A, when A is out front, it is a vertical stretch or a vertical shrink. And we also know that when it's negative, that means it's going to flip it over the x axis. We know that we have B. When B is inside with the x value, we know that this is a horizontal stretch, shrink, and we know that when it's negative, it flips it over the y. And then we finally have our last two things, which these ones should be pretty straightforward. H shifts it left or right. And one big thing I want you to remember is it's always the opposite of what you think it should be. And then finally, we have our last thing, and our last thing is K, and K just shifts it up or down. So those are all things that we've talked about before. We've gone through this. We've actually done it with absolute value. So really, there shouldn't be anything new or difficult with it. So all I'm going to do is I'm just going to jump right into some examples. I'm going to work my way through some of the examples in the book to make sure that you guys can see the examples as well, just in case you can't read handwriting or anything. But it should be pretty straightforward. Now we're going to be doing two different types of questions. First is going to be a graphing question. The graphing question is one that I would expect you to be able to do without a calculator. And guess what? The next time you come back to class, you will be doing this without a calculator. Okay? So that being said, you are going to see types of questions and how to work through them without a calculator, so that way it won't be too terribly difficult. I understand your calculator can graph these things for you, and I don't want that, okay? So you're gonna see that type of question, and then the second thing you're gonna see is, here is a general function, transform the general function, write the new function after you've transformed it. So those are the two things that we're gonna see, okay? So let's go through a few questions and we can kind of talk about and look at what these things look like, okay? So first things first, all of these are going to be asked to, or you're going to be asked to graph all of these. So there has to be kind of a foolproof way in order to graph these. So if I look at, like question number 28 in the book, question number 28 looks like this. It is f of x equals -4 times x plus 1 squared minus 5. So it's just a very straightforward problem. It has the same kind of stuff that we just talked about. And so we basically just have to identify these things. If I'm not allowed to use a calculator, this is going to get really challenging because I'm going to have to try to plug points in, blah, blah, blah. There's a really easy way to work this out without having to do too much terrible mental math. And it gives you every single one of the points at the same time. The first thing that you should do is identify the parent function. The parent function for all of these is going to be the same. It's going to be f of x equals x squared. I'm going to put that into an xy chart. And I'm going to put my three most important points, -1, 0, and +1. And these are the outputs that it's going to create. So I'm going to have the point -1, -0, 0, and 1, 1. So that parent function is going to look something like this. Oh, that's a good graph. But the parent function will look something along those lines. Okay? I know that line's not perfect, so let's retry. It's hard to draw on this Moby thing. That's better. Can we go 2 for 2? Better. All right, so that's our parent function. Doesn't really matter if it's perfect or not. But now what we're going to do is just walk through left to right what's happening here. This thing right here is a flip, and it's also a vertical shrink. But those are both applied to the y column, right? Because flipping vertically is going to make it go this way, and stretching and shrinking is going to make it go this way. So that being said, what I'm going to do is I'm going to multiply the y value. My pen's going crazy. I'm going to multiply my y value by -4, and that's going to take care of every single value that I need. -1 times -4 is -4. 0 times -4 is 0, and 1 times -4 is -4. This will take care of my new y value. Okay? Now, if I continue working left to right, this thing right here, that is going to shift my graph left 1 unit. Since it shifts my graph left 1 unit, that means it deals with the x's. Left means -1. So I'm going to take my x column and I'm going to subtract 1 from it. -1 minus 1 is -2. 0 minus 1 is -1. And 1 minus 1 is 0. This will take care of this column. And then finally, I have my last column, which is this one. This is going to shift my graph down 5 units. So shifting it down 5 units is going to take this column, because remember, up, down is the y value. This is my y column. So it's going to be that one minus 5. So -4 minus 5 is -9. 0 minus 5 is -5. And -4 minus 5 is -9 again. Okay? So now as we look at this, this column is no longer any good. So now this is my new x column. This is my new y column. Now all I have to do is graph it. So I have the point -2, -9. So -2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 is going to be somewhere down here. I'm going to have the point -1, -5. So -1 down -5, 1, 2, 3, 4, 5. And then I'm going to have the point 0, -9, and that's going to be right here. So then I can just draw my connecting lines here and here, and I've got my new parabola. Okay, that's it. All of these questions are done the exact same way. You just go left to right and decide which one is being applied to which. Okay, so you just pick one of the columns and then move your way through it, and you should be good. The only thing that could pop up here that we haven't really talked about lately is domain and range. Remember, domain is all the possible x values. All of these questions, that's not good. I just made a noise that this thing is not working right now. I don't know why. Come on. There we go. So domain is all the possible x values. So all of the possible x values, every single one of these quadratic function problems is going to have all reals for a domain. Every single x is legal to plug in. The range, on the other hand, is a little bit different. If I move my pencil up and down, is there any spot that my blue function is not going to touch the pencil? And I can see that anytime I go above this point right here and I keep going up, my pencil will never ever touch blue. But if I go below the red line, I can always touch the blue. So that means my range is going to be y is less than, and it's going to be -5. But now I have to decide if it's less than or equal to or just less than. And since it is on -5, it's going to be less than or equal to. So domain and range are pretty straightforward, but they are pretty important. Okay. So you'll have more problems in your homework like this, but again, I don't think we need to go through too many examples because this is exactly the same thing that we've been talking about before. Okay, so the next thing is to write and describe functions. It's to go through functions and describe what's going on with them. Okay, so if I look at a question like number 32 in the book, it says that I have the function f of x equals x squared, and it says that I have to do a vertical shrink by a factor of 1/3. It says I have to reflect over y, and it says I have to move it 3 units to the right. You always go in the order that it tells you to move. So if it says to shrink it, then reflect it, then shift it, that's exactly what you do. So you take this function right here and you just go one thing at a time. So it says vertical shrink. So when I vertically shrink this, I'm going to do f of x equals 1/3 and then x squared. Now, really important here, do not put this in parentheses if it's a vertical stretch or shrink. If it's horizontal, it would look like this, 1/3 x squared. These are very different. This is what vertical looks like. This is what horizontal looks like. So we have vertical, horizontal. Notice the difference. This is not right in this case. If this said a horizontal stretch or shrink, this is what it would look like. Since it says vertical, this is what it would look like. Okay, so I've now vertically shrunk this by a factor of 1/3. The next thing that it asks me to do is to reflect it over the y-axis. Now I have to think about what the y-axis actually is. The y-axis is the horizontal flip, so that means that's going to be a negative inside with the x. So now that's going to mean I take 1/3 and then I do negative x squared. In with the x. Do not attach it to the 1/3 because it's not attached to the 1/3 at all. It's attached only to the x. Now if I think about what this means, this squared is going to end up making that negative positive, right? Because -1 squared is +1. X squared is x squared. So really, this is not going to change anything. And it's going to put it right back to 1/3 x squared. If you think about it, if I have a parabola that looks like this, and then I tell you to reflect this over the y-axis, it's not going to move. The same thing is happening here. If you reflect over the y, nothing changes. Okay? And finally, the last thing says to shift the graph 3 units to the right. That, remember, that always happens in with the x, and it always is going to be the opposite. So if it says 3 units to the right, I'm going to subtract 3. So this is going to be 1/3 in with the x and then squared. Okay. The rest of this problem asks you to identify the vertex. So if you're going to identify the vertex, that basically just means where is my point going to be? And if you think about the origin, so if you think of the origin of a parent function, it's going to be right here. So think about what we just did. Did we move this point up, down, left, or right? We didn't move it up or down. When we reflect this point, it's going to stay right where it's at. So if I'm not moving this up or down any, and I'm only moving it to the right 3 units, 1, 2, 3, right here, my new vertex is going to be at the point 3, 0. This thing and whatever's out here, if there's anything out there, is going to tell you your vertex. So right there, I can see that I have a vertex of 3, 0, and I'm done. Okay? I'm not going to talk too much more about this because I want you guys to practice this. Hopefully that gets you a good start so that we can have a really good conversation when you come back next time. All right? If you have any questions, please don't hesitate to let me know. If you catch mistakes, let me know so that way I can at least send them out to you guys so that I can try to get them fixed. But I think for the most part, you guys will be able to make your way through it because it's the stuff that we've already talked about for a really, really long time. Okay? So again, good luck. Let me know if you have any issues. Hopefully this was short and sweet enough, but I will see you next time.